Hello everyone. So in this video I will solve problem 15.18, which asks us to obtain the Laplace transform for the functions shown in these two figures. So what I have to do is to write the expression for each of these functions and then obtain the Laplace transform of that function. So for g of t, the function on your left, we have three different portions. We have portion 1, 2, and 3, which are different steps. Why did I like separate them? Because each of them has a different height. So portion 1, for the portion 1, you see that I have a step going from 0 to 1. So that would be u of t minus u of t minus 1. So this is for the first portion, plus. For the second one, I have a step going from 1 to 2, but be careful that I have 2 as the amplitude. So u2 twice, u of t minus 1 minus u of t minus 2. So that would be for the second one. And then for the third one, I have 3 times, so 3 is because the amplitude of this step is 3. So 3 times u of t minus 2 minus u of t minus 3, and that is the third portion. Okay, so now I can simplify this and then obtain its Laplace transform. So g of t is equal to u of t plus u of t minus 1. Then I have minus 2 u of t minus 2 here and 3 u of t minus 2 here. So I'm going to have plus u of t minus 2 and then plus or minus 3 u of t minus 3. So now I have my g of t. I can find g of s using the table. So I know that u of t is 1 over s. U of t minus 1 is like I have 1 multiplied by u of t minus 1, right? So that would be again 1 over s multiplied by e to the negative s. We know that f of t minus a, u of t minus a, its Laplace transform would be e to the negative sa f of s. So I'm using this property of the Laplace transform. Then u of t minus 2, it would be 1 over s e to the negative 2s. And then for the third one, I will have minus 3 e to the negative 3s. And then I can factor out 1 over s. And I'll be left with 1 plus e to the negative s plus e to the negative 2s minus 3 e to the negative 3s. All right, so this was for g of t. Now I want to do the same thing for h of t. So first I have to find, so if this was a and this was b, here we found the Laplace transform for a. Now for finding the Laplace transform for b, again I have to write the expression for function h. So my function, as you can see here, it has 3 different parts. So one part is this first portion. Then the second one would be this constant line, and the third one is this one coming down. So how it is different from the step, so we still can see that we have a step going from 0 to 1. By step, I mean my function is increasing, right? Between 0 and 1. But how is it increasing? It's not a step. It's not a u alone, u of t alone. It is a ramp function, right? Going from 0 to 1. So what I have to do, I have to find the expression for this ramp function and then multiply it by that step that we have in that specific portion. So h of t will be equal to, let's see what is the equation for this ramp function. So at 0, I have 0. then when t is equal to 1, h of t is equal to 2. So we have 2t as the equation of this ramp, right? So here I'm going to have 2t, and then what is the interval that I had this ramp in? It was u of t minus u of t minus 1. Okay, then from 1 to 3, it is a constant, and the constant is at 2, so it's just a simple step function, right? So I'm going to have plus 2 u of t minus 2, or t minus 1, which is the beginning of that interval, minus u of t minus 3. All right, and then for the third portion, which is this line with the negative slope, I need to find the equation for that ramp with the negative slope over here. Okay, so what I have to do is let's have this function over here. So at 3, we were at h of t equal to 2, right? Then we go down here. So at 4, I'm going to be at 0. Okay, so h of t at 4. Now, if I want to find the slope of this function, the slope is actually the same as the slope of our ramp function in the first portion, only with the negative sign. So that there we had 2, here it would be negative 2. So the slope of this function is negative 2. And then when I want to write the expression for this function, I can say that, so we know that y minus y0 is equal to mx minus x0, in which y here is my h and x is my t. So what we have over here is y, which is my h of t, minus y0, where I started the line, which was 2, is equal to m, is negative 2. What is x is t minus x0, where I started the line. So t was equal to 3 at that point. So from here, I can say that, let me just separate this. So h of t is equal to negative 2t. Then I have positive 6 plus 2 plus 8. Okay, so that the equation for this line over here would be 8 minus 2t multiplied by u of t minus 3 minus u of t minus 4. All right, so now let's simplify these this equation. So h of t is equal to 2t u of t. Then I have minus 2t ut minus 1 plus 2 ut minus 1. So I'm going to have minus, or let me say plus 2 minus 2t ut minus 1. Then I have here, I would have minus 2 and then plus 8 minus 2t u of t minus 3 minus 8 minus 2t u of t minus 4. So h of t will be equal to 2t u of t. Then down here, I'm going to have 2 multiplied by, or I can say, so I'll bring a minus sign out. Then I'm going to have t minus 1 u of t minus 1, only because I need this argument over here, this function over here has the same like argument as u has. So you have u of t minus 1, then I'm going to need t minus 1 over here. If you look at this property of the Laplace, we have f of t minus a, u of t minus a. So then plus. So down here, I'm going to have basically 6 minus 2t. So if I want to make it the same as t minus 3, I can put a negative sign over here. And also I bring a 2 out. So I'm going to have t minus 3, u of t minus 3. Then in the last expression, again, if I bring a negative sign out, it would be positive and also a 2. So positive 2t minus 4, u of t minus 4. So now all the expressions that I have, I can use the Laplace table to find their Laplace transform. So h of s would be equal to, for the first one, I have 2t u of t, which is 2 over s squared. This one will be minus 2e to the negative s, f of s, which is 1 over s squared. Why f of s is 1 over s squared? Because you see here in the property, we have f of t minus a, u of t minus a is e to the negative sa f of s. Okay, f of s is the Laplace transform of f of t. Okay, not f of t minus a. So when I have t minus 1, u of t minus 1, okay, that will become e to the negative sa, which is negative s, and then f of s. So I come here, I have t minus 1. T minus 1 is my f of t minus 1, basically. So f of t is equal to t alone. Okay, then f of s would be 1 over s squared. Okay, so this was just an example for using this property. Then the same thing for the third term. So I'm going to have minus 2e to the negative 3s, again 1 over s squared, plus 2e to the negative 4s, or 1 over s squared. Okay, so now here, what I will have is that I can factor out 2 over s squared, although it's not required to simplify it unless you're asked to do so. So we have 1 minus e to the negative s minus e to the negative 3s plus 2, actually I factor out 2, so plus e to the negative 4s. Okay, so this was how we found the Laplace transform of these two functions. So I first wrote the expression for each of the functions, and then I used the Laplace transform table to obtain their Laplace transform. Okay, if you have any questions, please leave them in the comments down below, and thanks for watching.